Okay everyone, this is section 6.4. In this section here, our goal is to be able to find inverse functions. So starting off with a little bit of vocabulary, an inverse relation is a relation that interchanges the input and output values of the original relation. So here we have some data, some x values, some y values. So our original function's data has 0, 1, 2, 3, and 4, and corresponding y values. But for the inverse, what we're doing is flipping or switching the x and the y values here, which you can see. So the x values that were originally there are now the y values for the inverse. So for an example 1, we're going to find an equation for the inverse of the relation y equals 3x minus 5. So in order to do this though, we're going to find the inverse by switching x and y and then solving that equation for y. So I started out with y equals 3x minus 5. First thing it said, well, switch x and y around. So y becomes x and x becomes y. And now what we're going to do is just solve for y. So now I'm going to add 5 on both sides to get rid of that. So we're left with x plus 5 equals 3y. And in order to solve for y, the last step is to divide both sides by 3. So I'm left with y equals x plus 5 over 3. But that's kind of a really weird way to write it. Let's write it in slope-intercept form. So y equals 1/3 x plus 5/3. So always rewrite it in slope-intercept form. So here's our inverse equation of y equals 3x minus 5. Okay, an inverse function is an inverse relation that is a function. Functions f and g are inverses provided that if you plug one inside of the other, you're going to get back x. So function g is denoted by f to the negative 1. So that's really important here, that f to the negative 1 notation. That just means f inverse. So let's, in example 2, verify that these two functions, f of x and f inverse of x, or function inverse, are both inverse functions. So it just said in order to be true inverses, okay, they have to, when plugged inside the other one, they have to get back x or equal x. So one at a time here, we're going to plug one of them inside of the other and then vice versa. So let's start by plugging the inverse inside function f. So I'll make the inverse blue and let's see, regular function f red. Okay, so I'm taking the inverse and plugging it into function f. Well, function f starts with the 3, and instead of x, we're filling it in with the inverse, which is 1/3 x, plus 5/3. So we fill that in for x, but we can't forget to subtract 5 because that was part of function f. And now what we're going to do is distribute. So 3 times 1/3, well, that's just x. And 5/3 times 3, that is just 5. Because 3 times 5/3 is 15/3 or 5. And then we can't forget to subtract 5 on the end. Well, 5 minus 5, that's 0, so we're just left with x. So that's good. So that verified that side. But we have to make sure that the other composition works too. We got to take now f, regular function f, and plug it into the inverse. So the inverse starts out with 1/3. And instead of x, we're filling it in with function f. But we can't forget to tack on that 5/3 that was part of the inverse of f. So again, we're going to distribute. So 1/3 times 3x is just x, or 1x. Negative 5 times 1/3 is negative 5/3. And we can't forget to tack on regular 5/3. Well, negative 5/3 plus 5/3, that is 0, so we're just left with x, so that's good. So that these are inverse functions. So they are inverse functions. Okay. And any time you see that word verify up top there, okay, that means you're doing this two-step composition. You're plugging one inside of the other and then vice versa in order to verify that you get x back in the end, because that means they're both inverses or inverse functions of one another. In example 3, we're going to find the inverse of function f being x squared when x is greater than 0. Then graph function f and the inverse of f. Okay, so we're going to take function f, and we're first going to find the inverse. Well, there's no y yet, but f of x means y, so just go ahead and make it a y. And in order to solve, or we can't solve quite yet because we have to flip x and y, but now in order to solve, we have to take a root on both sides to undo that square. So we're left with y being the square root of x, or our function inverse of x being the square root of x. Okay, so here's our inverse of f. So we're going to first graph function f, and I'll make this red. So function f is a parabola that you can sketch. Okay, and we're only looking at a domain or x values of exactly 0 and greater than 0, so I'm only going to do the right side of the parabola. Okay, so here we go. Then I'll make the inverse blue. Okay, so if we think about that, we're only restricted to the x values of 0 or greater than 1. So if we think about that, we can make a little table out of that. 0, 1, 2, 3, 4. Okay, you know at 0 it's just going to be 0. And at 1, the square root of 1 is just 1. And the square root of 2, that's irrational, but the square root of 3, that's irrational, but the square root of 4, you know, is 2. So at 4, it's 2. So you know it's kind of going like a shape of this. And if you notice, it's kind of reflected. So the right side of the parabola is reflected over this line. The horizontal line test helps us to figure out if the inverse of a function f is also a function. If and only if no horizontal line intersects the graph of f, so regular function f, more than once. So if we test these out here, these functions, well, if I run any horizontal line through this first one, it's only going to touch in one place on the graph. So this one has an inverse that is a function. So the inverse is a function. So function f's inverse has, or is a function. It doesn't tell me that the function has an inverse. It just tells me the inverse is going to be a function. In the second one here, if I draw a horizontal line through any two or any points here through this graph, it's crossing twice. So this one says the inverse, or its inverse, is not a function. Okay, so in example 4 here, our last example, we're going to consider the function f here. We're going to determine whether the inverse of f is a function. So the first thing we got to do then is graph that and do the horizontal line test. So 2x to the third power and add 1. So here's our table. If I plug x and y in there, so -1, 0, 1, and 2, let's say. If I plug -1 in there, I'm going to get back -2 plus 1, which is -1. And I'll graph it in red. So -1, -1. If I plug in 0, I'm going to get back regular 1. If I plug in 1, I'm getting back 3. If I plug in 2, well, I'm getting back 17. And that's going to be clear off my graph. Okay, so you know it's going to be going up rapidly. So it's kind of like this S-shaped curve because it does have a degree of 3. Okay, and if we run our horizontal line test, if we run any horizontal line up and down this graph, the inverse is going to be a function. So that was our second part of information we needed. We determined that the inverse of f is also going to be a function. Okay, but now we have to find that inverse. So now I'm going to take function f and try to find the inverse now. Well, again, we need a y in there, so I'm just going to replace f of x with y. And now we're going to flip or swap x and y. And now we're going to start solving for y. So now I'm going to move the 1 over, so I'm left with x minus 1 is equal to 2y to the third power. We got to divide by 2 before we can work with the exponent. So I'm left with y to the third power being equal to x minus 1 over 2. So in order to get rid of that exponent of 3, remember we need to use the same type of root. So the exponent of 3 matches with the third root. So for y, we're left with the third root of x minus 1 all over 2. But our last step is to replace y with the inverse of f. So f inverse is equal to the third root of x minus 1 all over 2. So here's our function's inverse that is a function as well according to the horizontal line test.